Hello and welcome to another maths video with Mr. Thompson, and today we're looking at the level 2 graphing topic and a nice little exercise you can give yourself to really sharpen those skills around creating curves and fitting them to points. So the exercise is this: take any 3 points on the coordinate plane and just I try to choose a couple that are sort of negatives and positive, that sort of thing. So I've got 3 points. The point A is at negative 3, 5. The B is at 2, negative 1, and the point C is at 7, 4. And the challenge is to come up with two curves that connects those 3 points. Two different curves, two different types of curve that will connect the 3 points. So the way to do this, the simplest way to do it, I think, is to say, well, between points A and B, we're going to have a parabola. Thus, and it's going to be centred. The vertex is at point A, negative 3, 5. It's going to connect to the point B at 2, negative 1. The second point, the second curve, is going to be a square root function there, and it's based at the point 2, negative 1. It's going to go up and join the point C. So I'm going to basically do two curves in this exercise. One's a parabola with the vertex at negative 3, 5, and one's a square root function with the starting point at 2, negative 1. So let's focus on that parabola first of all. So first thing I'm going to look at that parabola is the domain. It's going to start at negative 3 and it's going to go as far as 2. So I'm going to specify the domain as that there, okay? That's the first thing. Next, I'm going to write the general form of the parabola, which is some value k, and because we know the centre's at negative 3, 5, we can say, well, it's the form x plus 3 all squared and a vertical shift of 5. Left shift 3, up shift 5. So I'm taking the basic parabola and moving it 3 to the left and up and 5 upwards. Okay, what happens now is we try to find the value k, that guy there, because that determines how stretched out or how tight the parabola is. And we're going to use the point 2, negative 1 to do it. So I can replace the value y with the value negative 1. And I can replace my value x with the value 2. And I can use this to solve for k. So taking the 5 across to the other side, I get negative 6. 2 plus 3 is 5 squared is 25k. So k is, there's my thing, negative 6 over 25. All I do now is replace that value k into my original expression, and I get the parabola I'm looking for, which is that. K equals y is negative 6 over 25, x plus 3 all squared plus 5. And that is that first parabola connecting A to B. Okay, let's take a look at the second curve, which is going to be my square root function, starting at 2, negative 1. So again, I go with the domain, which is between 2 and 7. So it starts at 2 there, and it goes up to the point 7 there. That's my domain for that function there. So I can write it. Now the basic square root function is y equals square root of x. I'm shifting it to the left, so that's why there's a negative 2 in here, and it's coming down 1. And that's why it looks like that. Again, I've now got to find that value k that determines how stretched out it is. Okay, so I've got a right shift of 2 and a down shift of 1. I'm going to use the point 7, 4, this guy up here, to find the value k. So replacing it back in again, so I've got 4 is my y value there, 7 is my x value there, and then I can rearrange that to find out what k is. So if I take the minus 1 across to the left hand side, I get 5. 7 minus 2 is 5, so it's the square root of 5 times k. Now, leave it as a square root of 5. Don't try and work out 2 point something. Square root of 5 is perfectly fine. Leave it as that. And that tells us that k is going to be 5 divided by the square root of 5, which is just a square root of 5. So I can now take that value k, fire it back into my expression, and there is the curve y equals root 5, root x minus 2 minus 1. Let's go to Desmos. Here's one I prepared earlier, and you can see in Desmos I've put these two curves in. I've got the parabola here, the red line, negative 6 over 25, and the other one is the root 5 times the x minus 2. Okay, so that's the first step of this. But let's take it to the next level. Supposing someone says, well, actually, let's do the same problem, but this time we're not told the point is 2, negative 1. Let's say this is some arbitrary abstract point with x coordinate p plus 1 and a y coordinate q minus 3. How does that affect all of their previous calculations? So what I'm going to do, I'm going to go through the exact same, there's what I'm working from before. I'm going to go through all of that and change whatever the 2, negative 1 appeared and replace it with p plus 1, q minus 3. Now, a top tip. Whenever you see your p plus 1 or q minus 3, put them in little brackets because you're going to be subtracting them and adding negatives and all that sort of thing. And there's no quicker way to make a mistake in mathematics than to get your negative signs mixed up. So protect them with brackets and then just let them do their work as they come out, okay? So, focusing on my parabola first of all. The domain is now no longer 2, the domain is now p plus 1. Right? And my basic function, well, it's still starting at 3 and finishing at 5. That hasn't changed, that's still the same up here. But what is changing is where it's going to. That point P is now my P plus 1 Q. So my left shift and my up shift are still the same. But I'm going to use K finding P plus 1 and Q minus 3. Just two abstract points, we'll just give them letters. And now I replace my expression with the new values. There's no longer 2, it's now p plus 1. It's no longer minus 1, it's now q minus 3. And now I repeat the exact same process, so I can remove all of that. Let's take that out, and we'll redo this. So my next line, so if I come down from here, so q minus 3, and I'm subtracting 5 from the other side, so I get that. And then I've got k, which is what I'm after, and that's now p plus 1 plus 3 all squared. So that's q minus 8 equals p plus k times p plus 4 squared. So my value of k, I'll just get it in the same line, so k is equal to q minus 8 over p plus 4 all squared. And put that into my expression, so y is now equal to k, is q minus 8 over p plus 4 all squared. And it's still x plus 3 all squared plus 5. And that's my new parabola between points A and B. I've specified the expression, I've specified the shift, and the domain is now that new value there. The square root function is a little trickier, but it's exactly the same process. Again, I'm replacing the point 2, negative 1 with the points p plus 1 and q minus 3. So, okay, let's look at the domain to begin with. The domain is no longer 2, it's now p plus 1. And this is a wee bit trickier because this time it's this value here. I'm now subtracting p plus 1 is my shift, my horizontal shift is p plus 1. So probably make that horizontal shift rather than right shift. And I'm now, vertical shift is q plus 3, sorry, q minus 3, I beg your pardon. Q minus 3. And so my vertical shift is q minus 3. And I'm still using 7 and 4 as the right hand point, the end point, but this time I'm going to be replacing this value in here. So the x value was 2, it's now p plus 1, and the minus 1 is now plus q minus 3, because that's that midpoint, the value of p. Okay, so I'm going to do all this working again, to find my new value of q. So I've got, I'm going to be taking that q plus 3, I'm going to take it to the left-hand side, so it's 4 minus q plus 3. Q minus 3, beg your pardon. Yep, this has got to be careful. Equals some constant k, and it's square root of 7 minus, and it's p plus 1. So I'm basically replacing that and firing it down here. Okay, so that becomes 7 minus q on the left-hand side, and q equals the square root of 7 minus p plus 1, so that's going to be 6 minus p. So my new value of k is 7 minus q. Oh, a bit messy. Still a bit messy. Over square root of 6 minus p. So my new value function here is going to be y, 7 minus q over square root of 6 minus p. And the x value is now x minus, and it's p plus 1 is my x coordinate there, and it's q minus 3 is that guy up there. Okay, so that's my new expression for the square root function. Let's go to Desmos and see what we did here. So I've got that one. Oh, excuse me. Where's my videos? There we go. So I've put that value in there of the p's and q's, and you can see that the top line there, I've got the parabola. Bottom line, the second line, I've got the square root function, and I've replaced p's and q's with sliders in. So if q, so that basically what I've got is what we had before. But if I move my value of q around, doesn't matter where I go. The curves stay consistent and stay within the two domains. Okay, so then you have two methods really. When you're given the value of a and b, value of b with actual numbers, and you can specify the values. In a more abstract situation, you're given just some random letters where it could be anywhere, and how the method stays the same, but instead of using numbers, you're using these p's and q's, and you have to be a bit more careful with that.